So as we move on to the very last part of the evaluation now, we come to headings D and E. And like the first three, these two at first might appear superficially very, very similar, but there are important differences. So these are kind of like two twins that look the same, but they're not the same, and it's important that you can tell the difference. So what I want to do in this video is to give you a few pointers as to what those differences might be. So now the first heading here is to suggest other data that might help your fieldwork. Let's go into the ArcGIS map of the Colin River where we were conducting our fieldwork. So for this one, it's imagining that when we were coming down through these different survey points, as well as doing width and depth and river velocity to work out the average river velocity, we could have collected some other pieces of information. So the question is, what other pieces of data could we have collected to go alongside width, depth and river velocity? Or in other words, what other aspects of the rivers change as you move downstream? Now, in many ways, this brings us right back to the planning stage of our inquiry and the very, very first thing that we did way back at the start, which was to identify the questions or issues for investigation. So what you did at that stage was to go into your rivers booklet and come up with some possible issues that we could look at, and in particular how do downstream rivers river channel characteristics change as you move downstream. So width and depth are there, but there are plenty of others that you could have listed. Now we chose not to study them this time to make this manageable in the time available, but we could have studied others. So what do they include? Well, if you come down a little bit here to the background theory section, you'll see some of those other aspects. So there's width, depth and average velocity, but there are things like this: the discharge increases, the volume of load increases, but also looking at things like the particle sizes are going to get smaller and more rounded due to attrition, and the gradient is going to go from quite steep near the source to much more gentle. So what you could have done in order to suggest other data that might help to explore that aim, remember the aim is let's go up here and find it. So the aim here is to investigate the downstream changes in river characteristics. We looked at 3. Other data to help could have looked at more of those as well. So that's what that section is looking at. What about the next one? Suggest ways of extending your research. So this isn't so much other data that we could have collected on the way down, but if we were conducting our fieldwork, say at an A level, are there ways that we could raise the level of complexity and the ways that we could extend it? And I would suggest yes. And the way that we could do that is by comparing the Colin River with another river in Northern Ireland. So the Colin River is interesting for a couple of reasons. If I turn on the geology layer here, you'll remember this from what we did before, that the geology of the Colin River changes quite considerably as you move downstream. It starts here on the top of the Divis Mountain, which is part of the Antrim Plateau. That is your layers of lava that cooled and hardened around about 60 million years ago to give you your basalt. Then as it comes down here into the Colin Glen, it comes down through this fault, and that's where the river is eroded, and it passes through an area here of limestone. Now that limestone was laid down probably around about 250 million years ago when Ireland was closer to the equator and underneath a tropical ocean, and the shells and skeletons were laid down to produce that limestone. Come down a little bit further again and you get into a section of the river with mudstone. So the geology changes quite considerably, even in that small stretch of the river that we looked at. Mudstone is much more vulnerable to erosion than your basalt would be, so we could expect the erosion rates here to be faster and higher as a result of the changing geology as you move down. But it's not just geology that changes as you move downstream, land use as well. You'll remember from what we did before that up near the source of the river, the land use here is your grasslands. It's very, very natural, but very quickly whenever you move down here into the Colin Glen, you move into this urban area. There's the red for the urban area. And the urban area is going to affect the river in some very significant ways, because you'll have your impermeable surfaces on the pavements here, and you will have the water flowing over those into the storm drains, and the storm drains feed into the river here. And that means that the river levels can rise very, very quickly as a result of this overland flow and the storm drains bringing the water into the river. And when the river has more water, it's going to have more energy and there's going to be more erosion. So there are two things that in particular change as you move downstream with the Colin River that make it quite interesting to explore. But what if we were to look at the Colin River and compare it to somewhere different in Northern Ireland? The Annalong River down here in the Mourne Mountains. Let's go down and have a little bit of a closer look at the Annalong River. The source is up here in the Mournes, and it flows down here through Annalong Forest, down, surprisingly enough, into Annalong in the sea. Now, if you have hiked in the Mournes at any stage, if you've parked at Carrick Little and walked up to some of the reservoirs here or on the Slieve Binion, you have walked right beside the Annalong River. In fact, you need to cross over it along the path at one point along here. So how does this river differ from the Colin River? Well, let's look at the geology first of all. Remember I said to you that the geology along the Colin River was very variable. Let's turn on the geology layer here and we discovered that quite the opposite is the case. The geology down here is granite, and for most of the upper course and the middle course of the Annalong River it's flowing through granite. There's a little bit of change as you come down here to the coastal strip, but for most of it it's flowing through granite. So what you could do is to compare the Annalong River with the Colin River. Compare a river where the geology doesn't change with a river where the geology does change. What about land use? Let's turn on that layer. Is there an urban area here? Well, yes, there is. It's called Annalong, surprisingly enough, the town here down near the coast. But if we trace the river back upstream, we discover that that is the only urban area that it flows through. So it's coming through the Mournes here, the upland grassland areas. There is a little bit of a forest near here, and then it's down through fields, farmland. So the landscape is much more natural, and there is no urban area near this part of the river which is going to be causing your overland flow to take place or anything like that. So those are a couple of contrasts in those rivers that would make a study and a comparison of them really quite interesting. Even though they're similar in length, the catchment areas and the drainage basins that they flow through really are quite different. So ways of suggesting to, or suggest ways of extending your research. What you could do is compare the Colin River and its land use with the Annalong River with very different land use. Compare the Colin River with its particular geological pattern here and the changing geology as you move down with the Annalong River where the geology doesn't change too much. So this one is whenever you were going down the river doing our actual field work, what additional pieces of data could you collect in order to fulfill your aim? Things like the pebble roundness and the pebble size, the gradient of the slope. This one is extending your research, so it's not only looking at one river, not only the Colin River, but an entirely different river as well.